All right, it's 8:05. Let's start for the day, everyone. I mean, Bhavani instead of everyone. Hi, Bhavani. Good morning.
Good morning, sir.
Great. Let's get started. Um, yeah, I hope my screen is shared. All set.
Yes, sir.
Yeah. So, Bhavani, yesterday we started with the concept of hypothesis testing, right? We learned that hypothesis is nothing but a statement, which can be a belief or a judgment or an assumption, which we want to try and test it out. Hence the name hypothesis testing, right? Now the statements can be with respect to the parameter of the distribution, can be with respect to the shape of the population, such as it can be statements such as my random variable follows Poisson distribution, my random variable follows chi-square distribution, or uh, with respect to its parameters, right? With respect to mu, sigma, lambda, p, correct? So we also learned that it's very important for me to understand why hypothesis testing. It is because I cannot directly go and completely study the population, right? Because of time constraints, resource constraints, given that the population can be too large at some point in time, correct? So that is why, I collect a sample from my whole population. Using this sample, again, my objective is not to infer on the sample. My objective is to infer on the population, right? So how do I do that? How do I ensure that whatever information I see in the sample, whether or not it holds true for the population or not, because I want to infer on the population, that is where the whole theory of statistical inference comes into the place, right? Within which you have theory of estimation and you have hypothesis testing, correct? So hypothesis testing is basically helping me get some confidence whether a statement or whether some theory, what I see in the sample, can also be, ensured that it also holds true for the population or not, right? Which is, in which is nothing but the mass data, what I'm interested in, what I want to try and test it out, correct? So we learned that the key steps in any hypothesis is, firstly you write down the hypothesis itself, then you define the level of significance. Since we are working in R, it really doesn't matter what the test statistic is. We have functions to work with a lot of stuff. And finally, we make our decision using p-value. So one, what do you call it? One key rule, what we wrote down yesterday was, if my p-value is less than alpha, right? Doesn't matter what type of test it is, doesn't matter whether it's a two-tailed test or it's a one-tailed test. If my p-value is less than alpha, then you reject your null hypothesis, right? This was one very basic general benchmark rule what we learned yesterday. Then we learned, I think, about five cases for tests: one population mean, two population mean, one population variance, two population variance, and finally we learned the paired t-test. So one key element we learned in paired t-test was that the observations, or my two samples X and Y, are no longer independent. They both belong to kind of the same source. For example, pre and post diabetic glucose score or the sugar score, right? So both the scores, pre and post, belongs to the same patient or the same individual, correct? So here, even though we call it as a paired or a couple observations, the final, the final distribution, what you get out of it, or the final test is kind of a one sample test only, or a one sample mean test only. Just that it works with a difference on the mean difference between the two, instead of just working with two random variables independently. Any doubts, in whatever we have, covered yesterday? Yeah, Ria.
Sir, actually, the three correlation coefficients, I couldn't
Mm-hmm.
understand how to interpret the graph, like what can be the correlation, like how it is uh, actually done.
Okay, fair enough. So you're saying whatever activity we did yesterday, looking just by looking at the chart, you were trying to comment or infer what the correlation coefficient would be. You're saying that that is something not as yet confident. Is,
Yes,
is is that understanding right?
yes, sir.
Okay. So see how it happens, right? There are three types of correlation coefficient what we saw yesterday. Now, out of these three, the Pearson's correlation coefficient is only capable of capturing linear relationship between the two, right? When I say linear relationship, I mean x and y, let's say hypothetically, correct? So when I say linear relationship, it simply means that it could be a straight line. So is this a linear relationship? Yes. Is this a linear relationship? Yes. Anything that can be, kind of put down into a straight line is what the Pearson's correlation coefficient is capable to capture and tell you appropriately, right? The problem arises the moment my x and y relationship goes a little non-linear. So if my relationship is something like this, if my relationship is, let's say, something like this, right? In such a scenario, anything that is kind of non-linear, right? For example, here, let's say if it's exponential relationship, then Pearson correlation coefficient kind of fails to understand this pattern and try to put it to you into numbers. Technically, if you see this blue line, there is definitely a relationship between x and y. You can see that as x increases, kind of y also increases. But the problem is that the rate at which y is increasing is no longer linear, it is exponential. Correct? Hence, Pearson in such a scenario is unable to capture that. Since it is unable to capture that in a range of -1 to +1, it starts to move towards zero because it's not able to understand the pattern because it is only capable of capturing linearity, which the exponential, kind of moves in a different direction. Is this first thing clear as to what Pearson is, kind of lacking in what direction?
Yes, sir.
Great. Now coming to the remaining two guys, that is Kendall's and Spearman. What these two guys look at is they don't technically, exactly are taking into account the type of relationship. They are saying, yeah, okay, whatever the relationship is. What they are seeing is that as far as X and Y are moving in the same direction, right? Monotonically, either it's increasing. So if you see as X increases, again, irrespective of whether it is the orange line or it is the red line or it is the blue line, as X increases, Y also tends to increase. So Spearman and Kendall try to take this into account. Okay, is X increasing, Y increasing? Yes. Now, some takes it in ranks, some, you do it via calculation of concordant or discordant pairs, correct? So it's all of that direction. If you remember, I used the term yesterday, something called as a monotonic direction. Monotonic means a single. Mono means single. Direction means in what trajectory you're moving. Either it's upward or either it's downwards. So as far as you are moving in the upward direction, right, they are good to go. Or downward direction as well. So if you see in this pattern, as x increases, y is also increasing. Hence, for this line, right, technically your correlation coefficient for Spearman and Kendall would be 1. But since Pearson is not capable to capture any non-linear patterns, the Pearson's correlation coefficient for this blue line would be, let's say, about 0.3ish, 0.2ish, a little more closer towards zero, what we were seeing yesterday. Is this understanding clear here? How exactly, we're trying to see the charts and try to make some comments.
Yes, sir.
That is why, if you remember, whenever I write rho equals 0 for Pearson's correlation coefficient, I don't say that my x and y observations are independent. It could also mean that x and y are not linearly correlated. I hope you remember this from your CS.
Yes, sir. Yeah.
Okay, great. All right. Um, Guys, anything else you want me to discuss from yesterday's lecture? So we just had a quick recap on whatever we did yesterday. Okay, thanks, Ali.
Sir, so,
Mm-hmm.
in the Pearson's correlation coefficient, it
Mm-hmm.
uh, basically takes into account both the magnitude and direction of the two.
Correct. Correct. Yes. Yes. It takes into account the magnitude. That is, if you remember yesterday, if I recall correctly, I showed you one example that the topper in your class have, let's say, scored 9.55 CGPA, and let's say the second ranker is 9.45, let's say. So Spearman actually takes into account the delta between these two guys, whether it is 9.5, whether it is 9.05, whether it is 9, whatever it is. Correct. So if there are two scenarios, someone have scored 9.55 and 0.5 versus 9.5 and 4.5. So here Pearson would actually take into account the delta of 5.5 and 0.10. While let's say Spearman would simply say this is one, this is two. Again, here this is one, this is two, because it works on ranks, right? So technically, if you see here, I never take into account the delta between these two guys. I just saw that this is first and second, end of story. Now, whether the delta is of zero point 0.1, zero point 0.5, or 5 units also for that matter, or 4 units also for that matter, 5 के नीचे तो fail हो जाएगा ना. Let's keep it safe. Let's say
Sir,
3 units for that matter.
if 10 observations, 10 observations, non-equal observations. So we have found Pearson's correlation coefficient. And non-equal correlation, it may be increasing. So if we do that Spearman correlation coefficient, this Pearson's correlation coefficient and Spearman correlation coefficient will be same, right?
So
If we have
it
a 10
depends, right? So it
observations,
depends on the data set. It may not
no, if
always be
we have a 10
exactly equal.
observations, if we have 10 observations and we
Mhm.
have non-equal observations, maybe monotonically increasing or
Hey, when
monotonically
you say
decreasing.
non-equal observations, what does that mean?
If 3, 3, if a 10, 10, that is a non-equal observations, na? So there won't be any tie as such.
Acha,
So
okay.
yeah,
Mhm.
so there was therefore we correlation coefficient, the absolute correlation coefficient, we found that it is 9.9 something. And if you do the same thing to Spearman correlation coefficient, rank correlation, it will be there is no tie as such. So it will be same, right? Correlation coefficient will be same, correct? No?
Yeah, fair enough. Yeah, I mean,
Correlation
again,
coefficient of
given that
co-
both
co-
of the guys move in the same direction, yes.
correlation coefficient of Spearman correlation coefficient and correlation
Fair,
coefficient of
fair.
this the other one
Mhm.
it will be same, right? Pearson's and correlation Pearson's and Spearman's will be same, right? Exactly equal tally, right?
No, you're saying Spearman and Pearson.
Yeah, because if it is a non-decreasing, so there is
No,
a
but if the
non-tally as such.
relationship is not linear, then it would not be the same, right?
Yeah,
If you would say Kendall and Spearman, I would still agree. Maybe
no, but
depending
they
upon the
have a
field.
linear relationships. They have a linear relationship.
Then yeah,
It will be same, correct?
not
Has to be
necessarily it will be the
it
same.
has to be same because all these is are
No, no, not
linear
necessarily.
relationship.
No, no,
So
not necessarily. Not necessarily. I don't think
actually
that
I
they would
found
be the same
I
only.
I tried with my Excel sheet. She is found
No,
to be
but
this
then
equal.
but then you would have taken a very deterministic relationship, which means your data points would exactly lie on the straight line, which the
Then it should be
reality
one.
may not come out. Sorry.
Then it should be one.
Absolutely. If you draw such a academic line, then it will be the same. But in reality, you would have some variations, right? In that case, you would not hit one, but the
I tried
spearman would
with
hit
an
one.
Excel. It found to be not a perfect correlation coefficient or correlation
Mhm.
between them, perfect linear, but it will be exactly same.
Okay, fair. We can do this activity, not a problem.
Excel we can do. I mean, we can do in Excel or we can do in R
Yeah,
also,
you
no
can do in
problem.
Excel and R also. Yeah, definitely. Fair enough. Don't worry, we'll do this. I mean, we'll just sit back today after the lecture, try this out and see. I am not confident that it would be the same every single time. That's what I feel. Because if you add a little bit element of non-deterministic component, right, such as random variation, things may go here and there at times. They may not exactly be equal. Fair. No worries, you can try it out and discuss it next class. Even I'll, just get back after the lecture, try and see if it works or not. And then we'll just maybe get back to you on it. Guys, great. Anything else? Ria, I hope this is clear. Anything else you want to discuss? Everyone else, others? Okay, great. So before we start for the day, we can just take so how do you want to start? Do you guys want to take some exam questions and then move on to new hypothesis tests? Or you want to take new hypothesis tests first and then finally move on to solving past exam papers?
We can do one exam question.
Fair enough. Great. Okay then. Yeah, let's start with this question. This is IFOA's question, right? If you can see my screen, it says INF. All right. Great. So there are total of 6 subparts in this question. Let's get started. Chalo, the screen is already up. I'll give you, let's say, about 5 odd minutes to solve this question. And then if you have any difficulties or you want me to solve anything, we can take some time to solve it together. Chalo, great. Get started, everyone. It's 8:22. Let's finish it till 8:27.
So can we get this screenshot of the question?
I'm not sure how can I get the screenshot here because last time when I tried copy pasting it, it did not happen. I'll just do that. So I've just taken a snapshot. When I come here, I click copy. um, Oh yeah, it's happening. Or yeah, it's happening. Done. Yeah, I'll also maybe paste or write down the second part of the question then. Yeah, done. I have pasted both the parts of the question in your chat box. Yeah, great. Yeah, both the parts are in the chat box, guys. So irrespective of my screen, you should be able to solve independently. Three more minutes left. Yeah, anyone wants to share their screen and get things started, please feel free to do that. Chalo, since you guys have both the subparts, I'll give you maybe about 3-4 odd minutes extra to finish the entire question first. And then, we'll start discussing the entire question in full. Yeah. So at 41, maybe I think we are good to start with the entire question to discuss it out. Yeah, obviously, if you have any questions or you're stuck anywhere, please feel free to let me know.
So what test, no? What
Yeah, Tom.
what dot test, no?
Uh, yes, absolutely right. The second,
Sample one, sample two.
correct. Absolutely right. The second subpart requires you to perform a var.test function given the particular scenario. Yes, absolutely right.
And the second one, we can do t dot test and put var dot equal to true.
Yes, absolutely. That's right.
B it is false, for the confidential interval. That it should be false or true, like that we have to give, no?
So confidence interval, you would get the same answer. The
Same answer,
You
like
will get the answer from subpart 3 only.
yes,
Because if you
yes,
remember, the same function gives you hypothesis test as well as confidence interval.
yes.
Correct.
So I just need to write the comment and the hypothesis. I just did the code part.
Mm-hmm. Okay. You were telling me that or you were asking me that?
No, I am saying that is left.
Yeah, okay. Go ahead. You have more time, right? I think you have another 2-3 odd minutes, so that's fine.
Sir, for the
Mm-hmm.
absolute deviation,
Correct.
we should use the t-test itself.
Yes. The question clearly mentions, right, that perform a two sample t-test on the set of absolute deviations at 5% level. So you will again use t dot test for the same. Yes.
So we need to first calculate the absolute deviations and then.
Yes, absolutely. That's right. Subpart 4A is asking you to calculate the deviations first before you perform the test. Chalo, do you want me to start with the second bit of the question?
Yes, sir.
Okay, great. Let's get started. Just for completion purposes, I also performed part 1, 2, 3. Great. So someone who wants to, just proceed forward with the remaining questions or the remaining subparts, great. Feel free to do that. Someone who's stuck want me to solve, so I'm starting with the question. That's also completely fine. So the very first subpart is enter data into R. I've already done that to save some time for us. Correct. Next, it says perform an F test at 5% level of significance compare the population variances. You should state your conclusion clearly. If you remember the very first step of any hypothesis, hold on.
Is equal to h1 h0 mu1 is equal to mu1 squared is equal to mu2 squared, no? And then versus mu1 not equal to mu2. Mu1 squared not equal to mu2.
Correct, absolutely. It is
Sigma square.
Yeah, it is sigma 1 equals sigma 2, and your alternative hypothesis is not H naught, right? So this is what my hypothesis is. Since it's a variance test, the function name is var dot test. This is something what we have already seen yesterday. We also solved one exam question, if you remember, on ramen curry, correct? The function is simple. S1, S2, I supply both of the vectors. Now, since it is already 95% level of confidence, I don't need to specifically write any other argument. I can just run the test and I'm good to go, right? So if you see the p-value is about 6.5%, what does that mean?
That means we have sufficient
P1 is
evidence
P1 is less
of
than
reflection.
5%.
Sufficient or insufficient?
It's
We have
Yes.
sufficient.
sufficient.
Yes. Since
It's
the
less
p-value
than-
is less, since the p-value is greater than 5%, you have insufficient evidence to reject the null hypothesis.
Yes.
Hence, H naught is true. That means both population have equal variances. See if you agree with me on that.
So can you
Yes.
show the output once?
Yeah, I'll show you the output ones. Yeah, this is what I've got. You should also get the exact same thing.
I think
Yes.
there is some mistake from on my.
Sorry, your output is not matching.
No, sir.
Maybe might have entered one or data points incorrectly.
Okay, I'll check.
You can just check that, not a problem. Great. So question 2 is done. You should state your conclusion clearly. We have already done that by writing down the conclusion of the hypothesis test. Question 3a says perform a suitability test for the null hypothesis that two population means are equal at 5% level of significance. Again, which test, guys, you would use this for the use here?
Two sample t-test.
T-test.
Absolutely. You would use the t dot test function. Again, S1, S2. And since we have already tested here that the variance of both the population are equal, I would set the var dot equal to true as well. Anything else, again, not required because it is 95% confidence level and I'm again trying to test for a two-sided test. So this is good to go for subpart 3a. So when you run this much, again, if you see the p-value is 44% approximately, again means the same story that you have insufficient evidence to reject the null hypothesis, which means that the population mean or the mean for both of the population is exactly the same. That is what you mean in subpart 3a. See if we are comfortable to move forward, everyone.
Yeah, but here we have to write the hypothesis again about the mean.
Yes, yes. Irrespective whether the examiner is asking you for the hypothesis or not, you will always write down the hypothesis first, then write down the code and the conclusion of that. So you will again write down the hypothesis here first that your both mu's are equal. And again, H naught will be not H1, H1 will be not H naught because you're trying to test for a two-sided element. Are you good to go?
Yes, sir.
Okay, thanks. Others, are we good to go with subpart 3a? Can we move on to the B and C part?
Yes, sir.
So the Bth part is nothing new. It just says calculate a two-sided 95% confidence interval for the difference of population means. Now, if you remember the hypothesis H naught was mu1 equals mu2, right? So if I just take mu2 on my left hand side, I hope you appreciate it would become mu1 minus mu2 equals to 0. That is what they're trying to tell when they're writing down interval for the difference of population mean. So it is exactly the same story, nothing new. So yesterday we have already learned that the same function kind of gives you the confidence interval as well as the hypothesis test. So technically in your subpart 3b, you just have to paste down this particular confidence interval. So if you remember it from your books, this is how you guys used to write it down usually. There's a comma in between and, and the 95% confidence interval, so on and so forth, lies between this interval. Simple, good to go everyone. Subpart 3a, subpart 3b. Easy. Any questions?
Yes, sir.
Okay, great. Would anyone like to help me with subpart C? Subpart 3C. Comment on the answer in part 3A and 3B. So this was 3A and this is 3B. Sorry, this was 3, my bad. This was
The
3A.
confidence interval, the value of the confidence, T, what is the value of the, right, is it, minus 7.252, this is the confidence interval. So if that lies between that T, the value of T lies between this thing, we should accept it a null hypothesis, right? If it falls outside that confidence interval, we reject it.
Okay, fair enough. Fair enough. Others, what is Tom trying to tell here?
It is that if our T statistic lies in this confidence interval, that means the confidence intervals confirms our acceptance of null hypothesis in the hypothesis.
Fair. Okay. All right. So guys, how do you comment out here is, so if you remember your decision from the T test, you wrote down the decision as H naught is true. That is, you do not reject H naught, which means both population have equal means. Correct? You say equal means, that is, you say that the difference between the two guys, the difference between the mean of the population is equal to 0. That is what H naught means, if you remember. Correct? However, looking at the confidence interval in subpart 3b, if you see, the confidence interval is nothing but for mu1 minus mu2 only. So this confidence interval is actually with respect to this quantity, mu1 minus mu2. If you see, you also have a 0 sitting in this confidence interval. My range goes from -7 approximately to a +3. In this range of negative to positive, I hope you would appreciate 0 also lies between it, right? That is why whether you look at 3A or whether you look at 3B, the conclusion what you draw that both of these population means are exactly equal holds true in both of the scenarios. That is what subpart 3C is asking you to put it down. Everyone makes sense? So what I'm trying to say over here is that whenever you have to comment down on a hypothesis test, you don't always exactly have to perform a hypothesis test. Even if you have a confidence interval, you can very well use this confidence interval to comment on your hypothesis test, right? So if I say that is the delta or is the mean between is the difference between mean of the two populations equal to 10, you can exactly see that 10 doesn't lie in this confidence interval, right? Hence you would go ahead and reject that null hypothesis. So I hope you also remember that how can you comment on a hypothesis test just looking at the confidence interval and conclude that both of these subparts are trying to tell the exact same story. One was with hypothesis, another one was with confidence interval.
Yes, sir. Like it came an exam for 2 marks, so I did using the confidence interval.
You're talking about your previous semester exam?
Yeah. Like something same came. So
Fair,
for 2 marks, I didn't do the hypothesis test.
fair. Makes sense. That's good one. That's a smart approach. Ali, Tom, I hope that clarifies. So it's more
Yeah,
on the
understood. You
It's more on the
understood the
null
difference between
hypothesis.
the difference between that value lies in the interval. We accept the null
Correct,
hypothesis. If it
correct,
is
correct.
above,
I think you
if it is
guys
beyond,
got a little confused with respect to test statistic. So test statistic is more when you are comparing it with tabulated. In confidence interval, I don't care, right? Whether the test statistic is positive or negative. It's no longer a part to look at. So I hope that clarifies.
Yeah, yes, sir.
Yeah. Tom, good to go.
yes, yes, yes.
Okay, great. Okay, so moving on next, everyone. Pay a little closer attention. This one is a little trickier to understand. It's easy though. So now, if you remember, yesterday we have very well learned that one key assumption of a two sample t-test is that sigma 1 have to be equal to sigma 2, right?
Yes.
Now, to further validate this assumption, we learned the two population variance test using var dot test and R, right? So now this question is saying that instead of var dot test, let's try to experiment some another form of test, right? Var dot test is one test what you perform. Let's try to experiment something else, right? So what they are trying to experiment over here is that they are saying calculate absolute deviations, right? Where they have also given you the definition of deviation, right? So they have given you that the definition of deviation is different between observed value and the mean of the sample. So basically x minus x bar is nothing but the deviation what they are talking about here. Fair enough. Then they are saying whatever vectors you get on the set of deviations, apply. Okay, before that, they are saying if the idea is they have same variances, then the absolute deviations for the mean would be exactly the same. Okay, fair. So what they are trying to tell is you have an entire distribution here, and let's say this is where the mean sits. So if you try to calculate the deviations of each data point from the mean in absolute sense, whatever it is, then these deviations, if they have the same variances, then they should tally. Guys, are you able to understand what the question is trying to tell?
Yes.
Yes. So let's maybe solve part 4a, then we can try to talk about it. So part 4a says calculate the two set of absolute deviations. Great. Let's go ahead and solve that. So it is part 4a. So for me to calculate two set of deviations, as we learned, it is the set of observation minus x bar, which is mean of S1. And I want to take absolute deviations, right? So I will also have to apply an absolute function on top of it. I hope you remember when I say absolute, it means mod. So absolute, when I say absolute, it's only the magnitude what matters to me, not the sign, right? So absolute of minus 2 is 2. Absolute of 2 is 2. Absolute of minus 100 is 100. Absolute of plus 100 is obviously 100 again. So it's only the number what I'm interested in a positive sense instead of considering the negative sign into account. I hope you remember the definition of absolute. So let's say I am just naming this as absolute deviation 1. So let's say I'm giving it AD1. Similarly, I can just copy paste it for write AD2. Good to go, everyone. This is nothing but is what my part 4a is trying to talk about. Part 4b is, so what they are saying that if your variances are equal, right, then mean of AD1 and mean of AD2 would be exactly equal. That is what they're trying to tell you, or that is what they're trying to test over here using part 4b. Everyone,
Yes.
Yes, sir.
Okay, great. So as we know, we use the function t dot test. I would supply the absolute deviations here as well, AD1, AD2, right? Again, we'll switch var dot equals to true as we discussed. That's a by default argument. Var dot equals to.
Standard deviation ഈ ഒറിജിൻ സ്കെയിൽ വെക്കുകയാണെങ്കിൽ മാത്രമേ ഉള്ളൂ.
I
ഒറിജിനൽ
am saying. Now, are you trying to say something? I think there was some movement from your side. Okay, it says 81 and 2 not found. I'm yet to execute these guys. Okay, fair. So now if you perform the test, that is nothing but your part 4b. It says 2 sample test, you have a test statistic value and you also have a p-value. So can anyone take a minute to tell me what will be the conclusion of this test now, given the p-value?
Reject the
Fair.
null.
Absolutely right. Since the p-value is less than 5%, you reject the null hypothesis. What does that mean now?
Means are not equal.
The means of the
Yes.
absolute deviation.
Absolutely right. The mean of the absolute deviation is not equal. What does that mean now? You guys are absolutely right. You reject the null hypothesis and you conclude that the mean of the absolute deviations is not equal. Agreed. But what does that mean in this particular scenario? Or the question is trying to get out of you guys?
For the absolute deviations in the given data, we don't get the conclusion as we got for the actual deviations what we have.
Yes. Very good. This is nothing but you're trying to answer subpart 5, which says comment on your conclusion in part 2 and part 4b. If you remember from part 2, you kind of mentioned that the assumption gets satisfied, right? That is both population have equal variances. However, in subpart 4b, the test got rejected, which means that as per your experimentation rule, if you remember, if you read this last line, the idea is that if the samples have equal variances, then the mean of absolute deviation should be the same, which is not holding true, which means that both samples do not have equal variances. Make sense? So kind of you have a contradicting answer or a conclusion from either of the tests. However, if you see the p-value, they are kind of very nearby. This got rejected by a very near margin. I hope you would appreciate that, guys. 5% is the benchmark. You got rejected at, let's say, about 4.8% approximately. So quite a close call. Everyone, do you appreciate that?
Yes.
Yes, sir.
Yes.
Great. So
Yes.
that is what this question was trying to tell you. Finally, sixth part is comment on whether or not the equality of the population means can be still be tested. Right? So what would you comment here? Can you still test for the equality of population means? So you kind of have
No.
contradicting answers from both of them. If you believe that this particular test is meant to be hold true, then technically you cannot no longer test. Maybe you will have to further look for a different test to try and see if that's holding true or not.
Because the variances cannot be equal. That assumption does not hold true. So we cannot do this test.
Yes, correct, absolutely. So as per this hypothesis, everything got kind of things are not kind of holding true. So maybe we'll have to find out another test or another way to try and evaluate whether that assumption is falling into the place or not. If yes, maybe we can be more confident to test out that hypothesis.
Sir, can you just repeat the comment of the last second part?
Last or the second last part?
Fifth, yeah.
Yeah. So in the fifth part, the comment is that you kind of have contradicting results. In subpart 2, you got the conclusion that you accept the decision that both population have equal variances. However, as per your new experimentation idea, the absolute deviations don't have similar means. Hence, you are saying that population variances are also not equal. So you kind of get two different conclusions, correct? However, the p-value kind of, if you see, it's getting rejected by a very near margin. My threshold is 5%, and I am sitting at 4.8% of p-value now. So kind of missing it by a very small margin. That's what we discussed in the subpart or in the fifth subpart.
Sir, what's the comment on the last part?
Yeah, for the last part, what we're trying to say is that maybe we'll have to, try to test it maybe via a third hypothesis now, because the first hypothesis and the second hypothesis, part 4b, are yielding us different answers. So we are not exactly sure on testing out the population mean. So maybe any other method to try to test out similar variances would be required over here. See if that is helping you guys.
Yes, sir.
Everyone else, Bhavani, Ria, Tom, is this question
Yes.
good to go?
Yes, sir.
So like the comment is for 2 marks, right?
Correct. Mhm.
So like we have to like write 2 points or something for 2.
Yeah, I think 2 works, 2 points. I think that should be the general threshold. I would say that you should consider 1 point, 1 mark as one mark as 1 pointer. So one is maybe on the decision, and another one is technically on as to what further measures you would take down, something like that. Good to go, Ria.
Yes, sir.
All right, great then. So we are done with one exam question. Let's get started with hypothesis testing again. So moving back to where we left yesterday, right? Let's start with test for correlation. Now in R, you have a correlation function to perform the hypothesis test called as core dot test. If you remember, the core function was only to give me correlation coefficient. Core dot test helps you perform a hypothesis test around it. Again, since correlation kind of works with a 2D element, you have to give x vector, y vector, and what methodology you want to adapt to perform the correlation test, whether it is a Spearman's correlation test, Kendall's tau, or Pearson's correlation coefficient. That's where you'll declare it over here. Now, one problem with this test is that you can only test the hypothesis whether correlation coefficient is equal to 0 or not, right? I cannot test whether it is equal to any arbitrary value rho naught. So if the examiner asks you that comment if the population correlation coefficient is equal to 0.6, you technically cannot test it via this hypothesis, because this hypothesis is only helping you work with 0, not 0, less than 0, greater than 0. Now 0.5 is also more than 0, 0.6 is also more than 0. Correct? So this is one key drawback of this particular hypothesis. However, examiner very popularly does ask to test hypothesis something like this. How would you still go ahead and try to comment on such a hypothesis, guys?
We go by the principal approach.
Sorry, we go by the principal approach. Okay. Anyone else?
Or by using the confidence interval.
Yes, very good. We can just look at the confidence interval to comment on this. If you remember, just in this exam question, we learned in subpart 3A, B, C that I can comment on a hypothesis test just by looking at the confidence interval as well. So I don't exactly always require to explicitly perform a hypothesis test. Correct? So let's say if I just take any particular sample here, So again, if you see the arguments between correlation test, it's method, Spearman, Pearson, Kendall, alternative less than greater than two-sided, and confidence level, that is 1 minus alpha. If you just try and test this out, see you have a 95% confidence interval here. So if I say, or if the examiner is asking you to test whether rho can be equal to 0.65, yes, you can see that 0.65 lies within the interval, hence you accept a null hypothesis. Can my rho be equal to 0.95? No. 0.95 do not lie in this confidence interval, hence you reject that null hypothesis or that particular statement. So I hope you appreciate that irrespective of whether I have a function or not, I can look at the confidence interval to comment on n number of hypotheses, whatever the examiner asks. Guys, see if this is clear.
Yes, sir.
Yes, sir.
Great. So yesterday we have already learned the types of correlation coefficient and how each one of them differs between them. Guys, are we confident with question 1 and 2?
Yes, sir.
Great. Thank you. And we have also discussed what about a test where rho equals rho naught. So looking at the confidence interval, you kind of comment it in this place. So I think correlation test is also completed in full. Good to go, everyone.
Yes.
Yes, sir.
Great. All right. Let's move forward then. So guys, the easier bit of today's lecture is over, right? So we move on to the next step today, to work with some new type of hypothesis tests, right? So we learn the two key chi-square tests now before we go on a break at, let's say, 9:50 odd. So we have about 50 odd minutes. So let's try to finish both of the tests, right? So that once we come after the break, we can have again a couple of past exam questions so that we are confident as to how do we apply all of these learnings in exam. Fair enough. Is the objective clear for the next 1 hour, guys? We will learn two chi-square hypothesis tests and then go for a break.
Yes, sir.
Yes, sir.
Great. Great. Now, can anyone tell me what statistical tool you would use if I were to check the relationship between how much marks you score in R versus the number of hours you have put in to study R?
Chi-square goodness of it, no?
Okay. So I just said any statistical tool. So it may not necessarily be a hypothesis test. It could also be a simple other metric as well.
Can you repeat the question?
Yeah, I'll repeat the question. The question is, if I were to test the relationship between, or how does your number of hours studied impacts your or affects the number of marks you score in our exam? What statistical concept would you use to answer, or would you use to evaluate this relationship? Yeah, Bhavan. Yeah, Ali, I think even you are trying to tell something.
Correlation.
The linear regression
Okay.
or the coefficient of determination.
Okay. Yeah, Ali, you have any other view?
If it is impact of the studying hours on the your result, it is regression. But if it's relation, I think it's correlation.
Fair enough. So technically regression will come in unit 4. So I get that where you guys are coming from, great. But here again, I'm mostly focusing on the relationship only, not exactly trying to predict something altogether. So yeah, absolutely correctly mentioned by both of you guys. It would be nothing but correlation coefficient, right? So yesterday, as Tom correctly mentioned, that correlation helps me, assess the degree of relationship between X and Y. Correct. Now, if it
Yes,
is
sir.
linear relationship, that is where you start to talk about Pearson's correlation coefficient. Fair, great, absolutely right. Now tell me, if I were to assess the relationship or associationship between whether or not you are present in the class and whether or not you get exemption in the paper or not. How would you assess such a relationship now? So in the initial part, my variables were, I'll write it on the screen so that you guys don't get lost. It was number of hours studied versus marks scored, right? Now I'm saying whether you were present for lectures versus did you get exemption or exemption status for that matter. Yeah, so for this one, you guys mentioned correlation coefficient. I'm just writing it down by a shortcut CC. For the second point, okay. Now, if you see, you guys are suddenly quiet, right? Now why you are not answering in the second sub part? What made you guys suddenly just go silent?
Yeah, because it is not, you don't have numerical quantities for this one.
Yes,
So that's why.
absolutely right. Absolutely right. In the first part, you are very confident to go ahead and say regression, correlation coefficient, because both of these quantities were numerical in nature, right? Marks scored are numbers 64.3, 34.5, 88, right? Number of hours studied again 1, 2, 3, 4, 8, 10, 15, 20. Both of these elements are numerical in nature, hence I could calculate correlation coefficient here, right? The moment you switch to the second question, you kind of moved from numerical to a categorical information, right? What do you mean by a categorical information? Basically, it's a non-numerical information, right? So whether I was present for the lectures or not is technically a yes or no answer instead of having some numerical information. Whether or not I got an exemption for CS1 or not is again a categorical question, yes or no, instead of having some numerical information, right? However, in such scenarios, the moment my variable goes from numerical to categorical, I can no longer use correlation coefficient. I hope you would appreciate, because correlation coefficient by the very definition and nature, we know it only works for numerical information. The moment I switch to categorical information, basically a non-numerical information, my correlation coefficient can no longer be used. Is the problem statement clear, everyone? I hope you appreciate that was the exact same point where what made you guys silent.
Yes, sir.
Great. Absolutely right. So now can anyone tell me for this, if I were to comment on this question, that whether or not there is any relationship or association between these two guys, whether or not you're present for the lectures or your exemption status, what type of statistical tool would you guys use? So this was correlation coefficient. I'm not predicting something. Regression is a fair answer for now. I'm not declining that. But again, I'm not too much keen to predict. Hence, I am sticking to a simpler version of correlation coefficient. What tool would you use for subpart 2? Okay, so one answer what we already have from Ria and Tom is that it's chi-square goodness of fit test. Okay. Yeah, Tom, you want to
Association,
add something?
association attributes.
Yeah, so what's the test called?
ANOVA.
ANOVA. Okay, fair. Anyone else would like to make an attempt? Okay, no worries. So guys, the test is called as chi-square test of association. As simple as that. Correct? Everyone, simple.
The chi-square goodness of it and attribute association also we use the
Yeah.
two-way
So
classification.
test of it is something different. Test of association is something what is different. Yeah, yeah.
Yeah, I had a doubt. Like
Uh-huh.
the two of them are different. Like I scored test of association and goodness. Are they
Uh,
different?
Technically, yeah, because what you're trying to get out of the particular hypothesis is different. Uh, so broadly, the heart of both of these tests are the same. I would not decline that. But what you're trying to comment or conclude in either of the test is very different.
Yes, sir.
So with
Because
the thin line of margin, yeah, you can say that both of these tests are different.
because in chi-square goodness of it, we are like basically checking whether this distribution, whether the sample follows a particular distribution.
Correct.
And here we are
That's
checking
right. I think you yourself answered the question. So there you are actually trying to work with some distribution at hand. Here it's simply trying to devise a relationship or association between two categorical variables. See if that makes sense.
Yes, it's fine now.
Yeah. So guys, if you remember, whenever you have categories, non-numerical variables, and you want to try and have an association or a relationship between them, that is where chi-square test of association comes between the game, right? You might have studied this in your last semester under the concept of contingency tables, or when you guys were studying sampling distributions. So
Yes,
under
yes.
chi-square tests or chi-square hypothesis tests, maybe under that header you might have studied. Irrespective, I hope you appreciate when would you use a chi-square test of association now.
Yes.
Chalo, great. That's good. So the null hypothesis is that there is no association between the two categories. Alternative obviously being that there is some association between the two categories. Is the hypothesis clear, everyone? No association and association. Simple, good to go.
Null hypothesis, no association, and the alternative is association, right?
Correct, correct. Absolutely, absolutely. So H1 means there is something to do between these two guys. So there is something to do with, if let's say, okay, so let me just draw one grid only and ask you guys to comment on that. So let's say my rows represents whether you got exemption or not, and my column represents exemption, and let's say the rows were you present or absent, right? So let's say, okay, let me put it this way. So let's say you were present, you were absent. Did we get exemption? Yes, no. So 50, 0, 50, 0. Unfortunately, we are not 50 students, so don't take the numbers in literal sense. Okay. So guys, you have two matrices here in front of you. Tell me which matrix demonstrates that there is association between getting an exemption and being present in class. So whether it is matrix number one, don't be in a rush to answer. It's completely okay. Take about 10 odd seconds, 15 odd seconds. Think carefully and then comment. Which matrix shows you an association between the two variables? Yeah, Ali, sorry.
First one.
Yeah, Ali, what was your answer?
First one.
Okay, the first one. Others, what is your view? Tom votes for the first matrix. Fair, great. Others? Guys, it's okay if you're wrong. We can attempt.
I also think it's the first one.
Yes, absolutely right. It is nothing but the first matrix. That is where if you see the observation are unevenly distributed in this 2 by 2 matrix, right? Versus if you see in the second matrix, you technically kind of say that whether you were present in the lecture doesn't matter. Whether you were absent in the lecture doesn't matter. Did you get exemption? It's all randomly distributed if you see, or it's all evenly distributed. Do you appreciate that, everyone? So if the matrix looks something like this, obviously there is no association between the two because things are not skewed towards one of the direction, which you clearly see here that if you are present, what is the probability that you get exemption? It's probability of 1. If you were absent, then what is the probability that you would not get an exemption? It's again 1. So kind of it's not evenly distributed. It is kind of biased or skewed. Now don't take biased or skewed in a different sense. Obviously here I am talking about association. So there needs to be some trend or some behavior within the data set for me to establish an association. Here I would technically not expect things to behave randomly, just like what you see in matrix number 2. I hope this example helps you visualize what do I mean by association when I say that. Guys,
Yes.
great. So how do you perform this test in R? It's very simple. You have a function called as chi-square dot test. The only thing you supply within it is something called as a matrix. We have already studied matrix in our unit 1. So you create a matrix, supply the matrix, end of story. That's it. Nothing else required. See if that makes sense, guys.
It's the
Yeah.
same matrix kind of thing like we made in contingency table.
Sorry, come again.
In the contingency table, we made a matrix kind of a thing for doing
Correct.
this.
Yes.
So
Yes.
that is it like the same thing or
Yeah, this is nothing but a contingency matrix only.
okay? So the matrix will be given. We don't have to calculate the values. Like
No, absolutely not. That's what R will do it for you. You just have to calculate the observed frequencies. Rest everything R will do it for you, including the expected frequencies, calculating the test statistic, calculating the p-value. Everything will be done by R for you.
Sir, my
okay,
question
sir.
is,
Yeah, Ali, sorry.
yeah, I have a question on the syntax of the test. The second argument, correct or does it mean?
The second matrix have no association, yes. Is
No,
that
no.
what you're trying to ask?
No, I am talking about the syntax of the test itself.
Mhm.
The second argument,
Correct.
correct. What does it mean?
Yeah, we'll talk about this one. We'll talk about this one. Don't worry. So that's a fair observation. So he's asking that we also have a second observation or a second argument here called as correct equals to. What does this stand for? Right. So we will talk about this. Don't worry, everyone. We'll quickly take one exam question to solve this particular part, and then probably we will talk about this particular argument at the very first place. Good to go, everyone.
Yes, sir.
Chalo, great. So I will quickly move on to my PDF screen. Great. So this is the question what you have, guys. Given the syntax, I will again put the snapshot of my syntax in your chat box. Given the syntax, perform the test and tell me what your conclusion is. Yeah. Go ahead. I'm moving back to my screen. I'll give you guys, let's say, about 3 to 4 minutes to get this through. At 9:20, we'll start to discuss. So let me know if you have any questions or if anyone wants to share the screen and solve it together. I'll quickly mark the attendance in the meanwhile. We had 3 lectures. We started at 8 a.m. Unit 3. Hypothesis testing part 2. Ronnie is there. Ria is there. Lee is there. And Tom is there. Great. Done. Do you want me to start solving, guys? I mean, I understand. I just introduced the function and threw a question on top of you guys. Do you want me to solve it?
Doing set 1
Okay.
minute.
Okay. Fair. Take your time.
So like for assigning the headers for the rows and columns, what was the
Not required. So it was row names and call names, but it's not required here. It's completely cosmetic because the whole heart of the data is these data points, what is sitting right within the
Okay.
matrix. So even if you don't assign these names, that's absolutely fine.
So 0, 1, 2, and 1, 2, and 3.
Not
Like
required.
for the,
Not required.
okay.
Yeah. So 0, 1, 2, and that 1, 2, 3 are nothing but row names and column names. Just for curiosity, I can let you know. So we have studied the row names function, if you remember. So you give the matrix and then you start writing 0, 1, 2, for example. Something like this. Similarly, if you want, let's say call names and then whatever is that. I think call names is 0, 1, 2. So at 0, 1, 2, and this is 1, 2, 3. This is how you assign it. But again, it's not required because um it's not exactly a part of the data matrix. So you can just uh, ignore it even if you want to, but even if you want to add it, that's completely fine. This is how you write it down. So you supply your matrix name here. I hope that helps to recall. Good to go?
Yes, sir.
Okay, great.
Sir, in the correct option, what to give? True or false?
You can just keep it to by default for now, or you can just keep it to false for now, however feels comfortable. We are yet to discuss this, so you can just switch it to false for now, maybe. Everyone done? Can we start discussing?
Yes, sir.
Great. So the question is simple, that the company is currently trying to analyze relationship between number of members covered in a single policy and the number of claims from such policies. Correct. So basically they are trying to see if it is, that maybe more members covered in a particular policy leads to more number of claims or vice versa, either direction. So it says conduct a test to, check if the number of claims is independent of the number of members covered in the policy. Right? Fair. So firstly, we'll have to create a matrix. So we'll have to supply the data, right? So let's quickly put in the data observations here. So it's 410, 390, 370. Get these guys back up here. It's 99, 87, and 93. Next bit is 37, 11, and 3. Great. Since I went by row equals true, I'll say that is true. Number of columns I require is 3. All good to go. The function, as we learned, is very simple. It's chi-square dot test. Supply the matrix. Set correct to false for now. Run, and you're good to go. Right? You have the output. If you see, it says 1.7 to the power 10 into 10 to the power negative 6. So definitely the p-value is very, very small. That is, it is less than 5%, which means that you have sufficient evidence to reject the null hypothesis, which means that there is an association between the number of members covered in a policy and the number of claims they make in the corresponding policy. See if everyone is in line with me with the conclusion. This is what we have done when you guys did it.
Yes.
Okay, great. Everyone, do you have the same answer? Any questions, any doubts? I hope it was a very pretty simple function, right? And
Yes,
we
sir.
have this technically for about 5 odd marks. So I hope you appreciate,
Sir, so what do
some
we
of our brownie points.
infer from this? What do we infer from this?
Infer from what?
The result that we got.
So you reject your null hypothesis, right?
This is approximately 0.
Yeah, absolutely. This is
Real.
approximately 0. So since 0% is, let's say, less than 5%, you have sufficient evidence to reject your null hypothesis, which
Okay, so
means
there is
that
a
you
situation.
say that there is an association between the number of policies, the number of members covered in a policy and the number of claims a policyholder makes.
Okay.
So these two categorical variables, let's say, are kind of correlated in the nature. Make sense? Good to go.
Sir,
Everyone, yeah, Bhavan.
sir, I did it with correct equals to true. That time,
And you will get a different answer.
no,
Yeah.
I got the same answer.
Your
That's what took me
guys,
down.
your x squared might be a little different if you can just check.
No, I got the same.
So maybe the difference is maybe a very marginal. That's why maybe I don't see it exactly. Technically, it should be some difference. Let's see. So if I just write $M, let's say statistic. So it is 22699. Okay. I just copy paste it to, let's say, true. Technically, there have to be some difference. Okay. Did it give me an error? Yeah. Right equals to is. Array, sorry, my bad. Let me give it a variable name test. Test equals to test m test statistic. Yeah, technically it's coming up to be exactly the same, irrespective. But we will take one scenario where you would, technically get some different results. So that correction maybe is too small for it to apply here. That's why maybe, we're not seeing any difference. But we will definitely see some scenarios where you will start to see that differential elements as well.
Okay.
Yeah. Great. That's a good observation. We'll try to, again, try to see once we discuss that correct before we move on to the break. Everyone good to go with the question, guys? Everyone?
Yes, good question.
The second part.
Okay. Sorry, yeah, you were saying something?
Yeah, there is a second part of the question which says,
Yeah, definitely. The second subpart also says extract the degrees of freedom used. I think that again comes directly in your output here. So you can just kind of copy paste the same code or put a snippet of this particular output, highlighting that the degrees of freedom is equals to 4. So again, kind of a free 1 marker question. Ali, I hope that helps.
Yes, sir.
Okay, great. Now I have a question for you guys. A little out of syllabus, but that's fine. It will just take 2 minutes. So can anyone tell me one problem with this particular test what I have performed? So we performed the test, we concluded on things. But any disadvantage you are able to kind of draw out when you're performing the test?
First, we are not assuming any distribution for the data.
Fair, but then that has to be a good one, right? Why it would be a disadvantage?
Because always non-parametric test is much more accurate than non-parametric test. No? Because type 2 power of the test, type 2 power of the test is much lower than that non-parametric test. No?
Okay, fair enough. Others?
One of the frequencies is very less, no, in the table.
Okay, that's fine, right? Here I had 0 in my example at least. Yeah, Bhavani.
Sample size. Like
Okay, fair. Sample size, all right.
very large sample size, it will be hard to in this.
Okay, fair.
No, can you spell out the question once again?
No, yeah. So any disadvantage of this particular test, what you feel is helping you, kind of hinder your analysis or not give you kind of a detailed view about the association between the two variables.
Yeah,
So when you come, so sorry.
it
So when you conclude, you just say, there is association, there's no association. You get to know whether there's a relationship between the two or not. So do you think that there is some disadvantage with that? Yes, sir.
Yeah.
Yeah, Ali, sir.
it doesn't give you the exact how the two data are related.
Correct.
The extent of the association.
Yes, absolutely right. So kind of via this hypothesis test, I only get to see whether there is an association or not, right? Now, if at all there is an association, to what extent is the association? How strong is the association? Now, if I just say there is correlation, you would always be curious to understand, okay, what type of correlation it is. Is it moderate? Is it perfect? Is it strong? What type of association or relationship is that, right? In this test, you just say association or no association. It's a binary outcome. Whether it is strong, moderate, or how strong is something what this test lacks to inform you, right? So to solve this problem, that is to help you comment on how strong the association is, you have a test, not exactly a test, you have a concept of called as Kramer's V quantity, right? So Kramer's V statistic helps you comment on the association, right? How strong. So Kramer's V is a value which lies between 0 to 1, right? So obviously more closer towards 1 means more stronger association between the two. And 0 means, technically kind of very weak or no association between the two in a way. Good to go, everyone, about the Kramer's V statistic. Again, not in our syllabus, but it's okay. It's good to know. It's good to know the disadvantage and how to try to tackle it out. Simple, good to go. Yes, no, everyone.
Yes, sir.
Yes, sir.
Okay, great. So I'll quickly come to the last argument and then we'll go for a break. That is to talk about this argument called as correct equals to, right? By any chance, do you remember Yates correction from your earlier semester? Yates correction, YATE.
So to make it more continuous, for discrete becomes continuity corrections. So sort of a continuity corrections or what?
Yeah, not exactly though.
No, sir, we didn't have that.
We didn't study this, sir. We studied only continuity correction.
Okay, fair, great. So guys, one assumption in a crude way of performing this test of association, or if you remember even from your chi-square goodness of fit test, the assumption is that EI have to be at least 5. I hope you remember that.
Yes, sir,
Yes.
but we didn't do the
fine.
name.
Yeah, this is not the age correction. Hold on. So this is one key element that you have to satisfy when you are working with chi-square hypothesis test. Can anyone tell me why is this a key requirement? Yeah, a little quick, guys. Why do I have such a requirement here? Okay. So if you remember, your test statistic is assumed to follow chi-square distribution in these tests, right? Now, however, it is said that if your EI is not at least 5, then this approximation to chi-square may not hold true, hence making your result invalid. Correct? That is why researchers have come up with this assumption that your EI have to be at least 5 in order for the approximation to chi-square distribution of your test statistic to hold true. Is this justification clear, everyone? So to ensure that the test remains valid, you need to have this particular condition or criteria. Yes, no?
Yeah, but I'm trying to understand that why it's not valid. What's the reason behind it?
Because, so see, test statistic is a quantity, right? It tends to behave basis some formula. Now, however, if my EI values are quite small, so if you remember the test statistic, it is nothing but summation of OI minus EI, the whole square divided by EI, right? So if you see EI kind of sits in your denominator, so the test statistic as a final number may start to misbehave a little if EIs or your frequencies or expected frequencies are very, very small. I hope you would appreciate that.
Yes.
Right? So to ensure that the test statistic don't misbehave, it's important that you say that, okay, my expected frequencies have to be at least a minimum of 5. So that my entire summation is not blown away by this denominator quantity. I hope you remember, right? A number divided by a very small number is a very large number. Guys, do you appreciate? When I say
Yes.
1 divided by 0.1, it is 10. But if I just add another 0 over here, see the number goes 100. If I add another 2 zeros here, it goes to 1000, 10,000. So a number divided by a very small number leads to a very large quantity altogether. I hope you appreciate that.
Yeah.
So I don't want my quantity to misbehave, and obviously I don't want my test to become invalid. Hence this criteria or this condition. Ali, I hope this makes sense. This makes sense or
Yes.
this is helpful.
Yes, sir. Yes.
Great. So assuming I'm just drawing one random grid again. Right. So again, let's say this is exemption or not. So let's say you were present, you were absent. And let's say, did you get exemption? Or I would just change this to result status. So I would make it pass, fail, and let's say exempt for that matter. Correct. So assuming this is an EI grid, I hope you remember in chi-square goodness of fit test, you might remember something called as OI and EI. OI was observed frequencies, EI was expected frequencies. So let's say this is nothing but the expected frequency grid, right? Again, I'm just plotting some random number. Right. Let's say whether you were present in the class, yes, and you got exemption. Let's again 50. I'm just putting anything random, right? There's no objective over. Okay. So if you see guys here, this cell, can I say have a expected frequency of less than 0? Sorry, have a expected frequency of less than 5?
Yes, sir.
So technically, if you remember, you never used to keep this category on its own. You say that since the EIs are getting less than 5, club it with something else. So let's say I can now club my result status into a grid which looks something like this. So let's say I say pass plus exempt. Sorry. Let me change the grid actually. Let me make the data something like this. Yeah, 50-50. Just for easier explanation purposes, I'm doing that. So now when I say if there are three categories with one EI less than 5, then technically as per the assumption what we studied that EI has to be at least 5, I can no longer sustain this grid. So that is where the concept of clubbing comes into the place. Concept of clubbing says that you start to combine two columns such that the EIs now start to increase. So technically instead of having three columns, you would say pass plus fail and exempt. Right? These are the only two columns what I have with me now. So the frequencies gets added. So 50 plus 50, 100. 0 plus 50 is 50. And exempt both cells are 50-50. So this is what the new matrix or the new grid what you get. Guys, do you remember it from your chi-square goodness of fit test as well? You used to club wherever the frequencies were too small in terms of expectation. Is this
Yes.
clear
Yes.
or it's going heavy or we are not able to understand this? Guys? Okay, thanks Ali, Bhavani, Ria, Tong. Okay, thanks Bhavani, Ria. Okay, great, thanks. So now if you see my frequencies are more than 5, expected frequencies are more than 5. Hence, I can directly apply the chi-square test here. Now, assuming hypothetically this cell was 0, right? Now, can anyone tell me what will happen if this cell is 0? Again, assumption is violated. That's absolutely there. But now, can I further go and club any two these two particular columns? Can I do something like EI result status P plus F plus E? Make it 150 and 50. Can I do this?
No.
Why? You're absolutely
Because
right. You cannot do that. But why
yeah,
I can't do that?
because here you have
Then
one column.
degree of freedom becomes 0, no? The 1 minus
Yes. Yes, absolutely right. If you remember the degree of freedom, I'll just write down the formula here if you don't remember. It was nothing but number of rows minus 1 into number of columns minus 1. Right? Since in a 2 cross 2 matrix, I have 2 rows, 2 columns. 1 into 1 is 1. I have 1 degrees of freedom. Here I only have one column. So 1 minus 1 becomes 0. Basically, degrees of freedom goes to 0. Hence, you can no longer, right? Hence, you can no longer get or condense or club this matrix further. So 2 cross 2 is my hardcode bottom limit. I cannot further condense the matrix to increase my expectation of frequencies. This is where the Yates correction come into the game, right? Yates say that, okay, I understand that if any of one of your EIs is less than 5, in a 2 cross 2 matrix, you can no longer further start to club things because the DF will go 0. And if you apply the test as it is, your chi-square test may be a little invalid because of the assumption being violated. Hence, Yates correction or the Yates continuity correction adjusts the test statistic in a way that the extent of the assumption violation can be restricted. See if this is making sense. And again, repeat myself. Since I can no longer condense the grid, as well as my assumption gets violated, Yates correction ensures that the extent of approximation that may fail is being curved by applying some form of correction on the test statistic. See if we are good to go with this. Guys, सबका मौन व्रत है क्या?
No, sir. Got it.
You guys ask me question now and I'll show thumbs up. Okay,
No,
good,
sir.
great.
No, sir.
Got it, sir.
Okay, Ali,
Each
sorry.
correction is only for each correction is needed because to avoid the degree of freedom becomes zero, we have to
Yeah,
apply the
yeah,
each correction. The each
yes,
correction apply only after that clubbing, after clubbing only, no?
correct.
Before
Yeah,
coupling.
yeah, absolutely. So you cannot go beyond 2x2 now. That's where I have to start applying it, because beyond 2x2, I still have options to club. Below that, I don't have any option. Ali, was it clear? Was the entire journey clear? Where does that correct equals to come from?
Yeah, yeah. Yes.
Great. So I'll quickly just demonstrate you guys. So let's say I have just taken this sample grid here, right? So I've just created a matrix of 0, 0, 25. And again, I'm trying to perform a chi-squared test of association here. So if you see, R automatically gives me a warning. It says chi-square approximation may be incorrect. If I just write test dollar expected, you see it gives me the expected frequencies here, in which 3 cells are 0. Hence that warning. Guys, you never got warning in this test, correct? The M, or for that matter, for this particular exam question, what you solved. Oh, I think I deleted that. Okay. Let me just rerun it. I just change it to M. Yeah. So for this particular one, if you see the expected results, you see none of the frequencies are less than 5. Hence, you never got a warning for this particular exam question you guys solved.
Yes, sir. Got it.
Got it?
Yes, sir.
Chalo, great. Great then. So with that, Yates correction and chi-square test of association closes. One last thing what we're remaining is with chi-square goodness of fit test. I think let's have a quick break, because chi-square goodness of fit test would take some time for us to get, comfortable with that question. Um, all right, great guys. I hope this entire thing is quite clear. So Bhavani, technically, when you add a correction, the test statistic definitely changes. We can again. So I think I have 2 pointers for me to go back home and kind of debug or try to understand. One is what Tom had in the morning. That Pearson and Spearman would have same correlation coefficient, which I am not very comfortable seeing, because with some random variation introduced, they would not have the exact same CC. If it's a deterministic trend, then definitely. If it's a straight line, or if it's continuously moving in an exponential trend, again, exponential Pearson doesn't cater to. So if it's a very much steep and linear degree line, then yeah, they would have same correlation coefficient. Otherwise, they would not. Second is, we can just try to understand why, Yates correction did not have any impact on the question we try to solve. Right. So I think first one is something what is a little more clear. Second one, we can try and understand why there was no impact of the Yates correction. Good to go, everyone?
Yes, sir.
Yes, sir.
Yes, sir.
Great. Let's take a quick 10 minutes break. We connect back at 57. Right? Chalo. Great. See you. Bye-bye.
Yes.
All right, guys, are we back? Guys, are we back? Can you hear me? Guys, can you hear me? Okay, great. So Bhavani, I was thinking on your question, and I think we missed one very silliest of things. Is that in this question you're working with the 3x3 grid, right? If you remember via this very definition of the matrix what we're trying to study, the main issue comes and we start to apply it once you have boiled down everything to 2x2. Here things were at a 3x3 level, hence it did not make a difference. If you kind of try to, take a 2x2 grid and try to perform on that part, that is where, you'll start to see a lot of differential in the test statistic and the p-value, right? So I think that one base crux of 2x2 matrix got kind of wiped away. That's the reason I think, you were not able to see differential when you applied, because the whole construct comes when things starts to boils down to 2x2 matrix. I hope that helps. Others, guys, do you appreciate that? That's what, or that is the reason why you did not see a differential in the p-value or the test statistic. Guys,
Yes, sir. So
Oh.
like if it is 2x2, then it would have worked, but
Yeah,
it would
so
have
it
not.
kind of simply ignores if it's a matrix beyond 2x2. Yeah. Because the whole point of boiling down comes only when you are at a 2x2 matrix, because I cannot further condense or squeeze the matrix down. Unlike in a 3x3 or a 4x4 matrix.
So beyond that, if we have a matrix that is not 2x2, then we are not required to write the correct is equal to true or false, right?
Fair enough. Yes, yes, yes. Good to go. Let's go forward. Everyone, guys, are we back?
Yes, sir.
Yes, sir.
Okay, great. Thank you. So, guys, moving on next with the chi-square goodness of fit test. I think we have already studied this now a couple of times, or revised the concept a couple number of times. Again, the concept is very simple. If I have a sample data at hand and then I want to try to kind of, comment whether this sample comes from a specified distribution or not, be it Poisson, gamma, log normal, normal. Now, one thing what we learned as an alternative was to work with QQ plot. Now, obviously, QQ plot is more of a pictorial or a graphical tool. Chi-square goodness of fit test being a hypothesis test, right? So the hypothesis is very simple, that the sample data is a good fit to the set distribution. Now, the set distribution can be anything what you want to test against. It can be your belief, it can be your assumption, anything of those forms. And obviously, H1 is that it is not a good fit. So it's a binary situation again, whether things are good fit or things are not a good fit. Fair. The function again is very simple. The function still remains the same what we learned in chi-square test of association. It's chi-square dot test. All you supply over here is the observed frequencies, and you calculate and supply the expected probabilities inside the p argument over here, right? So if you remember right from the test statistic again, what we wrote over here between OI and EI, OI is what you supply, EI is what R automatically calculates basis the probability. So if you remember the formula of EI, it was N into probability. So since I'm supplying the P part, R will automatically calculate N and compute EIs. Right? I hope this makes sense, everyone. You remember this formula.
Yes.
Great. So let's try to take one quick question, two quick questions, and then I will give you time to solve one exam question. So the question is consumer panel preferences for three proposed store displays are as follows. So basically there are three types of TV companies, A, B, and C. The store or the shopkeeper wants to understand as to which display they should keep on the store, right? Or which type of TV they should put on the display. So they are, they just ran a survey and then they kind of understood that which customer prefers which type of TV or which company of TV so that they can appropriately put that TV on the display of the shop. So you have to test whether all three displays are equally likely or not. Correct? So which distribution is this?
It is uniform distribution.
Distribution is
Which,
uniform distribution, discrete.
which, absolutely right.
Uniform
This is
distribution.
nothing but a discrete uniform distribution, everyone. So I'm saying all TVs are equally likely, which makes it a discrete uniform distribution. Guys, do you appreciate that?
Yes, sir.
Okay, great. H1, obviously not H0. Chi-square test is very simple. You supply the observed frequencies. So let me create a vector for OI. Right, let's say that is 43, 53, and 13. I'm just copy pasting my observed frequencies here. Again, so the story is simple. You write OI, the argument P equals to will take probabilities. Now, what probability should I fit in here, guys? What is the expected probability for each of the display?
1/3.
Absolutely right. It's 1/3. So either you can write 1/3, 1/3, 1/3, or you can use the REP function to repeat, right? So you say repeat 1/3. How many times do I want to repeat 1/3? I want to repeat it 3 times. Either of the thing would give you the exact same answer. Obviously, the REP function helps you, eliminate a lot of duplicate activities of the same. So I don't have to write 1/3 3 times, 5 times, 100 times. REP function just helps me repeat the same, just one with one few shorter level of lines of programs, right? So when you run the program, it says why not found. I did not execute this one. Okay. So if you see, you have again the chi-square test statistic, the degrees of freedom, and you have the p-value. Since the p-value is more than 5%, you have insufficient evidence to reject a null hypothesis, which means that all TVs or all manufacturers of the TVs are equally likely, which means that discrete uniform distribution stands a good fit over here. See if this is making sense, guys.
Oh, so can you repeat the last?
I
Hello,
lost
sir.
your voice actually. You want me to repeat the? Yeah, I
Yeah,
can hear you. Yeah.
can you just repeat the last inference?
Yeah. So the inference is that you do not reject a null hypothesis, which means that all TVs are equally likely. So kind of discrete uniform distribution fits well here. See if that is making sense.
Yes, sir.
Okay, great. Guys, was it simple, clear, good to go?
Yes, sir.
Yes, sir.
Great. So I will give you guys a question then. Obviously, the easier one is for me to solve, and the difficult one is for you guys to solve. Great. So this is the question. Apply chi-square goodness of fit test to test this particular hypothesis. Great. Go
Can
ahead.
you get
I'll
the
give you
question?
guys. Yeah, I'll paste the question. Thanks. I'll give you guys about 7 odd minutes. At 10:15 sharp, we'll start to discuss this. Sorry. Yeah. 10:15 start, we'll start to discuss this with you. Yeah, I pasted the question in the chat box. You can start to use that. Acha, just one more thing, guys. I forgot to mention. When I say chi-square goodness of fit test, I hope you guys appreciate and understand that this test is not used only to test if my sample comes from chi-square distribution, right? It is termed as chi-square goodness of fit test, or it is termed chi-square test of association, because the test statistic follows chi-square distribution. I hope that is very clear with us.
For
So
any,
I can use a chi-square goodness of fit test to check for my sample coming from Poisson, negative binomial, binomial, geometric, gamma, Weibull, Poisson, Pareto, any of this distribution. It's only because of the distribution of the test statistic I call it as a chi-square test of good, or chi-square goodness of fit test, or chi-square test of association in the other problem statement. Yeah, Tom, we're trying to tell
for any
something.
distribution, no, we have to see the theoretical distribution, then and observe distributions. So then we have to compare. No, we can use it. No?
Correct, absolutely. But then the test statistic follows chi-square. So it's not that my expected distribution only can be chi-square. So students often confuses the name with this thing. So I just thought I'll just clarify that it's not that case. Guys, good to go.
Yes, sir.
Okay, great. Get started. Obviously, in case you're stuck or you want me to get in at any point in time, let me know. We can start discussing. Chal, take your time, get it through. We'll discuss it.
So for this question, we need to take out the lambda value. I cannot hear you, sir. Okay.
Actually, we have to
So
find them fit the Poisson distribution, no, theoretical distribution,
Yeah,
or
yeah,
so
correct.
automatically there is a
So,
command for that.
using MOM, we can find the lambda value.
yeah, correct.
That's
Using
the
M1, you'll have to find lambda, and since you'll have to put in the probabilities here,
yeah.
so I mean, you're absolutely right. For Poisson distribution, for me to calculate any probability, I'll require X and the lambda value. So lambda, since not given in the question, we'll have to estimate it. Either it can be using MLE or MOM. Doesn't matter in this case because MLE and MOM yields you the same result of the
Yes.
estimate of lambda. So yeah, the first step will be to calculate lambda and then move towards calculating the probabilities. That's right.
Okay, sir.
Yeah.
Is
Great.
there any utility function is there to calculate the theoretical distribution? Observed
No,
distribution, theoretical distribution, no. There is just any command is there.
no, no. To calculate what, you have a command.
No, the theoretical distribution. we have observed distributions are there. We have already given.
Yeah, you'll have to
Theoretical distribution.
supply the probabilities, right? So to
Yeah.
calculate probabilities from theoretical distribution, you have D
Any,
poise, P
is
poise.
there any suppose if we give lambda, is there any utility library utility function or something like that to calculate the entire frequency of theoretical frequencies of Poisson distributions? Any
No,
utility functions?
you can calculate the frequencies using probabilities, no?
No,
Why
but
do you
we
require a
have to give
function? You already have a function to calculate probabilities. You just multiply
each
it
and
by
everything.
summation of y and you have the expected frequencies.
Each and everything we have to give now. Probability means each and everything we have to give function. Then you have the iterative function we have to use now. Then
No,
it will
no.
be a
This is just
it
a
takes time.
one-line program. This is just a one-line program. No.
Line program.
It's
Okay,
only
okay,
a one-line program. That's
okay.
it. Make an attempt, otherwise no worries. We will definitely try to solve. Guys, I'll be just back in a minute. Please solve in the meanwhile. Yeah, I am back. So can we start discussing, guys, or you need some more
Yes.
time to make an attempt?
Yes, so we can discuss.
We can discuss. Great. Let's get it started. Okay, so can we conclude that the data comes from Poisson distribution is what the question I have at hand. Now, the very first thing, right, I require to feed in the chi-square test is the observed frequencies. So let's create the vector for observed frequencies. I just copy paste the frequencies from here. Oh, sorry. So it is 114 and 111. Sorry. Good to go. Now, so OIs are sorted. I have to supply probabilities also here now, right? Inside the P argument. Now for probabilities, if you remember, this frequency is nothing but for the random variable x equal to 0. This frequency is nothing but for random variable x equal to 1. So the probability is what I actually feed in here should also be catering to probability that my random variable x equals 0, probability that my random variable x equals 1. Now, since I want to test against that x comes from Poisson, obviously this probability statement would have to be computed using the Poisson distribution. Correct? Now, how do I calculate PMF in R for Poisson distribution? What key letter have we studied, guys?
D.
Good. We use
D
D.
pose.
And since the function, absolutely right. Since the distribution is Poisson, you write D Poise. Good. Now D Poise takes in two arguments. First is the X value, which already I have in the question, 0, 1, 2, 3, 4. Right? So that is not a problem. The problem is the lambda value, which is the second argument, which is not given to you in the question. Right? So now yeah, sorry. Yeah, Ali, you have anything?
No, sir.
Okay, great. So, guys, to calculate lambda, if you remember, as per MLE or MOM, lambda is nothing but x bar. That is the sample mean of the distribution, right? Now, over here, if you remember back from your, PNS theory, this is nothing but a frequency table, right? When I have a frequency table, you might have seen this formula of x bar, right? So it is kind of a weighted average of x where weights are nothing but your frequencies, right? So it is something like this, if you remember. So you're kind of weighting things. When I say weight, it is WEIGHT, not WAIT. So this nothing but factor acts as weights or helping you kind of do a weighted average, right? So can I say OIs are my frequencies? I need to now work upon X. So X, what I have over here is 0 to 5. Now I hope you appreciate it does says greater than or equal to 5. But again, I cannot calculate mean if I have an open-ended statement or an open-ended range, right? So you would assume that this frequency whole and soul, let's say, belongs to 5 only. So you will consider this number as 5 only. So this is my OI, this is my X. Basically, I have my X and I have my frequencies here. Correct? So how would I calculate lambda? Any guesses? How would I compute this formula in R?
Summation x
Good.
into OI
Summation. Very good. Summation of OI into X divided by summation of OI. See, it's the exact same formula what I've written down over here. Sum of X into F, sum of X into F, divided by sum of F, divided by sum of F. Guys, are we good to go with this?
Yes.
Great. So I have my lambda. Okay, I did not run anything 0x. Yeah. Great. So I have my lambda value estimated as 0.251 approximately. Great. Good to go. Next comes calculation of probabilities. So since the probabilities goes from 0, 1, 2, 3, 4, instead of calculating them individually, can I just write 0 colon 4? So if you remember, I will have 5 probabilities here. Probability that x is equal to 0, x is equal to 1, x is equal to 2, 3, 4. See if that makes sense, everyone.
Yes.
Great. So now, if you remember for the last probability, again, if you remember, one of the assumptions in your chi-square goodness of fit test is that summation of OI is, summation of OI is equal to, guys, Summation of y is equal to it is equal to summation of ei. Do you remember this assumption?
Yes.
So summation of oi can be equal to summation of ei if your summation of probabilities is equal to
One.
absolutely right. Good. When your summation of probabilities is equal to 1. So by default, always remember it as a benchmark or as a threshold or as a thumb rule that you will always calculate probabilities the for all of these rows except for the last one. So if you remember, the fifth row is my or the sixth row is my last one. So I will calculate all probabilities up to x equal to 4. That is what I have done here. And the last probability for this particular cell will always be 1 minus sum of the probabilities that you have calculated above. See if that makes sense. It is just to ensure that the entire summation of the distribution or the entire distribution tallies to 1. Otherwise, your this equation would not hold true, and in R would also give you an error saying that probability are not summing up to 1. Is this clear, everyone? You will keep it as a thumb rule that you will always calculate probabilities for every one of the random variable except for the last one, because the last one would be calculated as a complement for the earlier probabilities or the summation of earlier probabilities. See if that is making sense, guys. Yes, no?
Yes.
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 Great. So I will calculate this just for your clarification. I will also show you guys sum of probabilities. If it is not adding up to 1, then something is wrong. So here it comes exactly as 1, and it should always come exactly as 1, not 0.9999 either. Great. So things are good to go, everyone here. Yes, no. So once I have the probabilities, things are very simple. You get the chi-square test, calculate OI, get the probabilities into the game, run the test, and great, you're good to go. So you have the test statistic value and you have the p-value. That is 50%. So you say that again, since p-value is more than 5%, you don't have sufficient evidence to reject null hypothesis. Hence, you conclude that the random sample comes from Poisson distribution. As simple as that. Simple, good to go, everyone.
Yes.
Great. Can anyone tell me one issue in the output? So we definitely have the output. But there's one issue with the output. Anyone?
Yes, sir.
Yeah.
We have degree of freedom equals 5.
What it should
It has to be. It should be 4 because we estimated lambda.
Yes, very good. Absolutely right. If you remember, guys, every estimate you make in statistics leads to loss of 1 degrees of freedom. Since I have about 6 number of frequencies here, right? Your degrees of freedom become number of rows minus 1, which becomes 5, 6 minus 1, 5. But it also has to be 5 minus 1 because you estimated lambda. Lambda was not given to you. So technically, R does not account for that estimation. You yourself will have to account for that. Correct? Everyone, is that making sense?
Yes.
How do you account for that? I will quickly help you guys understand that. If you remember, how do you calculate p-value for chi-square goodness of fit test? It's very simple, right? It is the probability that the chi-square distribution will take a value more than the test statistic, right? So if this is where my test statistic lies, then the entire area beyond this point, this region is where my p value, or this area is nothing but my p value. So how would I calculate this area under the curve using which key letter?
Q points.
No. Is this quantile or is this probability?
Probability.
So which key letter would you use here? You said Q, na? If I heard it right.
Yes, I
Huh.
was wrong.
See, Q is used to get this axis, this data point. I want the area under the curve. For area under the curve, you use,
P.
very good, you use P. So it will be P, complete the statement. P
P points.
is the distribution of test statistic Poisson distribution.
P guys.
Very good. It will be P chi-square because the test statistic follows chi-square distribution. What is the test statistic? The test statistic is 4.3285. What is the degrees of freedom now? It is, let's say, 5 for now, just for you to appreciate that this 5023 will exactly match with what we calculate. Anything else required? Is it right to left or is it left to right?
Lower dot tail.
Very good. It will be also lower dot tail set to
False.
false. Good. So if you see, the answers exactly tally. 50315, which when rounded off to 4 decimals will turn out to be 5032. Now the only difference here, as Ali correctly mentioned, that the degrees of freedom would be set to 4. So your p value becomes 36% approximately. Irrespective, again, the decision still remains the same because 36% is also more than 5%. Hence, you again accept your null hypothesis and conclude that your sample observation does follow Poisson distribution. See if that is making sense to all of you guys. In exam, you would only perform the simple test if at all the examiner is asking you to recorrect the p-value. Is only then you would go ahead and do the p chi-square and all of those different shapes and form. Else you would perform whatever is the by default function. This is, I have just introduced in case the question comes and it is asking for a corrected p-value, then you should know how do we do that.
So
Is
this
the
is
entire
basically calculating. Oh, sorry.
Yeah, I was just asking whether the entire story is making sense and are we clear with that?
Yeah,
Yes.
sir, actually, so the p-value is basically the probability that the chi-square
Test statistic,
degree, test statistic is greater than the, no, sorry.
the
This,
distribution, the random variable is greater than the test statistic value. So what is the probability of you seeing even more extreme event than what you are currently seeing in the data set? That is how you read it.
because we use basically the percentage point table, so that's why we are seeing the greater than part, and that's why the lower tail is false.
So in chi-square goodness of fit test, you always see the greater part.
Yes,
Because
yes.
if you remember the test statistic, it is OI minus EI the whole square in the numerator, if you remember. Right? So since it is the whole square, if my observed and expected are not nearby, then the square term would try to explode all of these numbers, right? I hope you appreciate that. Hence, you would, or the test statistic would start to take a lot more larger value. Hence, moving on the right hand side. Hence, you always see or always have that error on the right hand side of the tail, never on the left hand side. See if that helps.
Yes, sir. Yeah. Okay.
Great. Anything else, guys? So I'll just display my program to you guys in case you want to type it down, or if you're comfortable, and if you don't want, even if then you don't want to type it down, that's completely fine. Guys, is the understanding clear, everyone?
Yes.
Great. Do you want some time to write this down, or how do you want to move forward?
Yes, sir.
Okay, great, great. I'll give you some couple of minutes. Feel free to write it down. Then we close for the day. So if you have any questions, again, please feel free to let me know. Yeah, Tom, are you there? Yeah, so guys, I'll just quickly also wrap up the session by, answering to what Tom had the question, if I got him right. So he was saying that if there's a linear relationship between the two, x and y, and if I'm trying to calculate Pearson's and Spearman's correlation coefficient, so he had the understanding that both of them would turn out to be the same, which technically shouldn't, and that's what you see on the screen also, that they are nearby, but they will not exactly tend to be equal, right? So I hope that makes you understand, because it's a randomized data, right? Not exactly things will be in the same picture for them to tally. If I just remove the random component and if my entire distribution looks something which is very deterministic, then yes, both of them would exactly tally to one. Otherwise, which I hope you appreciate, right? Such a perfect relationship in a practical world is not possible. You would always have some random variation in the data set. So even though both of them broadly they are trying to tell me the same story, that there's a strong positive relationship between the two, numerical wise, that quantum or the magnitude may not exactly turn out to be the same. So I hope that's clear. Everyone, Tom, in case you heard that. Yeah, Ali,
Yes.
any doubts?
No, I was just saying this.
Okay, great. So no homework for me as well. I wrapped up both the questions within lectures only. But again, you guys will not go without homework. You guys will have homework. So cool. Done, everyone.
Yes, sir.
I'll also paste the entire thing in the chat box for you to have a reference. Cool then. I think we can stop here for the day, guys. Next class when we meet, we finish with hypothesis testing. Again, we will take a couple of past exam question papers to help us understand and get more hands-on on R. So I think next week, whenever we meet, I think two again Saturday, Sunday, I believe, we will close with unit 3, right? So unit 4 remains, and I think we are well ahead of time as far as syllabus completion dates is concerned. Most probably, I'm planning to close everything towards the end of March. I think the official dates are 12th of April for me to close. I think we will be closing well before 2.5 weeks prior for exams, right? So you'll have good about time to revise all papers and set for the exam. Yeah, you have anything?
So what is the topic for the 30 marks? Like for 30 marks, which topics can be asked for?
So it is usually linear regression or GLM in either of the parts. The other one is usually a mix of principal components or bootstrapping or hypothesis testing. So we are yet to study PC and bootstrapping. That we will come at the end of unit 3 and end of unit 4 respectively. But yeah, so one question is majorly on linear regression or GLM, that is unit 3, sorry, unit 4. And another question is usually a mix of hypothesis testing, bootstrap, and PC, what I mentioned. So it's a mix. So one is kind of deterministic, one is kind of a mix. So it's a surprise. It can be anything, something like that.
Okay, so we'll have an option between that.
Yeah, so you have an option in question 3 for 30 marks. You can either solve A or you can either solve B in full. Good to go?
Okay. Yeah.
Chalo, great then, guys. Let's close it for the day. Let's connect next week. I think I've shared all scripts for unit 3 with Ria and Kosto. So even today's script is already with you guys. So practice again. If you have any questions, doubts, errors, feel free to message me anytime you're comfortable. See you guys next week then. Let's try to close unit 3 as soon as possible and take more exam questions. So
Thank you.
see you. Thank you. Bye-bye.
Thank you, sir.
Thank you.
Thank you.
Bye-bye. Thank you.